Welcome back, everyone. Today, we're unpacking Qwen3. Is it the affordable AI revolution we've been waiting for?
It certainly got people talking. Alibaba's latest large language models, the Qwen3 series,
Yeah.
well, there's definitely a buzz.
Yeah, a lot of excitement, especially around their performance games, considering the size and the open weight approach.
Exactly. 8 new models dropped, which is quite a release.
8. Okay, let's break that down. What are we looking at?
So it's the third generation Qwen3, and they've given us a range from zero point 0.6 billion parameters, really small, up to a massive 235 billion.
Wow, okay. Quite the spectrum.
Right. And they're positioning these to compete with the big names. Think OpenAI's latest Gemini 2.5 Pro, DeepSeek R1. They're aiming high.
That's ambitious, for sure. And you mentioned different types.
Yeah, two main architectures. You've got the dense models, 0.6B, 1.7B, 4B, 8B, 14B, and 32B parameters. Standard stuff, relatively speaking.
Okay, the dense ones. And the others.
Then there are two mixture of experts, or MOE model. There's a Qwen 330B A3B.
Hold on, 30B, A3B. What does the A3B mean?
Good question. It means it has 30 billion total parameters, but only 3 billion are active during inference at any one time.
Ah, okay. So potentially more efficient?
That's the idea. And the other MOE is the big one. Qwen 3 235B A22B. So 235 billion total, 22 billion active.
Huge numbers. And a key point, I think, is the license for the dense models.
Absolutely. The dense models are under Apache 2.0. That's a big deal for commercial use, much more permissive.
Right. Less friction for businesses wanting to build on them.
Precisely. It signals they want broad adoption.
And the performance claims. I heard some chatter about smaller models doing surprisingly well.
That's one of the most eye-catching things, yeah. They're claiming, for example, that the Qwen 3 4B model, just 4 billion parameters, can rival their own previous generation, Qwen 2.5 72B Instruct, on some benchmarks.
Wait, 4 billion versus 72 billion? That sounds almost too good to be true.
It does, doesn't it?
Yeah.
A nearly 20-fold difference in size for supposedly similar performance in certain tasks. We always need to take benchmarks with a grain of salt, but still.
Definitely something to watch. And the flagship, that 235B model.
That one's being positioned against the absolute top-tier DeepSeek R1, Llama 3, Grok 1, Gemini 1.5 Pro. An open weight contender in that space is significant.
And back to the MOE efficiency, that 30B model with 3B active.
Right, the Qwen 330B A3B. The claim there is that it outperforms the previous dense Qwen 32B model,
Okay.
while using considerably less compute during inference because only those 3 billion parameters are active.
So the promise is large model knowledge with smaller model running costs.
That's the pitch. Of course, you still likely need the full 30 billion parameters loaded into memory, so the hardware requirement isn't that small, but the actual processing crunch is theoretically less.
An important nuance there. Okay, beyond the models themselves, what features are they highlighting? I saw something about thinking modes.
Yes, the hybrid thinking modes. This is pretty interesting. They offer two modes. One is thinking mode.
Okay.
Right? Here the model actually shows its work, basically. It outputs its step-by-step reasoning process within special think tags.
Ah, so you can see how it got the answer. Useful for complex stuff, I imagine.
Exactly, like debugging logic or understanding the rationale for a complex analysis. Then there's non-thinking mode.
Which is just the answer.
Pretty much. Quick, direct responses. Optimized for speed when you just need the information fast, no explanation needed.
And developers can switch between these.
Yeah, that's the neat part. You can toggle it using an API parameter, like enable thinking, true or false,
Simple enough.
or even within a prompt using commands like think or nothing. So you could, say, ask a complex question in thinking mode, then follow up with a simple one in non-thinking mode.
Flexible. They're calling it flexible thinking.
Right. The idea is you control the depth and potentially manage costs. Use the compute-heavier thinking mode only when necessary.
Like for that financial analysis example versus just checking an account balance, it's an interesting control mechanism.
It is. Could be genuinely useful, or maybe a bit fiddly for some use cases. We'll have to see how people use it.
What else stands out? Anything on coding or agents?
Definitely. They're stressing optimization for coding and what they call agentic capabilities. Support for MCP multimodal chat protocol was highlighted.
Okay.
And improved tool calling, which is crucial for agents that need to interact with external APIs or software.
Makes sense. The ability for models to do things, not just talk.
Exactly. And they've released Qwen Agent, a framework specifically for building agents using these models. Clear focus there.
So they're pushing the agent angle hard. What about the training? Anything unusual there?
It sounds pretty comprehensive. Pre-training was apparently a three-stage process.
3 stages.
Yeah. Stage 1, basic skills, trained on a massive 30 trillion tokens with a 4K context window, foundational stuff.
30 trillion, okay.
Stage 2, knowledge focus, another 5 trillion tokens concentrating on STEM, code, reasoning.
Right, specializing.
And Stage 3, long context, training specifically to handle longer inputs, pushing up to 128K tokens for the bigger models.
So a huge data set and specific stages for skills, knowledge, and context links.
Seems thorough. And then there's post-training, especially for those models with the hybrid thinking.
Ah, right. What did that involve?
A 4-step reasoning pipeline, apparently. Things like long chain of thought prompting, reasoning-based reinforcement learning,
Okay, getting technical now.
a thinking mode fusion step, and general reinforcement learning across lots of different tasks. It sounds quite involved.
Does all that complexity translate to better real-world use, do you think? Or is it more about the research paper?
That's always the question, isn't it? Benchmarks are one thing, actual usability is another. But the effort seems significant.
And accessibility. We mentioned the Apache 2.0 license.
Crucial point. Open weights under Apache 2.0 for all models. That really lowers the barrier to entry.
Big advantage over closed models.
And the multilingual support, they're claiming capability in 119 languages and dialects.
119, that's huge. Truly global ambition there.
It really is. Makes them potentially very versatile.
Let's circle back to the tech, specifically the MOE architecture. Can you break that down a bit more?
Sure. So mixture of experts. The core idea is you have a large pool of specialized expert networks within the larger model.
Okay, like specialists?
Kind of. For Qwen3, they mentioned having 128 total experts in the MOE models. But when you feed it an input token, a routing mechanism selects only a small subset of those experts, reportedly 8 out of the 128, to actually process that token.
Ah, so only 8 specialists work on each piece of the input.
Exactly. The others remain inactive for that specific token. This means you get the potential knowledge breadth of all 128 experts.
Because they were all trained.
Right. But the actual computation performed at inference time is closer to that of a much smaller model, because only 8 experts are firing.
That's the efficiency gain they're talking about. Knowledge of a big model, speed closer to a small one.
Theoretically, yes. That's how the Qwen3 30B A3B 3B active can supposedly match or beat the older dense Qwen32B.
Makes sense. And the parameter counts again for the MOEs.
Qwen3 30B A3B, 30 billion total, 3 billion active, and Qwen3 235B A22B, 235 billion total, 22 billion active.
Still massive numbers, especially the 235B. Trained on 36 trillion tokens, you said.
Yeah, 36 trillion for the pre-training of these latest ones, up from 18 trillion for Qwen 2.5, and lots of multilingual data in there.
Context window.
32K tokens for the smaller dense models, up to 128K for the larger dense ones, and both MOE models. So pretty long context handling.
And running these monsters, quantization must be key.
Absolutely essential for practical deployment, especially locally. They seem to quantize well. Reports suggest even 2-bit quantization works surprisingly okay.
Wow, 2-bit.
But 4-bit seems to be the sweet spot for balancing size reduction and performance. Still, even a 4-bit version of the 235B model needs serious hardware, think hundreds of gigabytes of RAM or VRAM.
Yeah, not exactly running on your laptop just yet.
Not the biggest one, no. But the smaller models, especially the dense ones like the 4B or 8B, become much more accessible on consumer hardware with quantization.
Okay, so how do people actually get these models? Where are they available?
Multiple places. There's the QuenChat web interface for trying them out directly.
Like a ChatGPT interface?
Pretty much. Then for developers, they're on Hugging Face, ModelScope, even Kaggle.
Standard hubs.
Right. And deployment frameworks like SGLang and VLLM are supporting them.
And for local use?
The community's been quick. Llama, LM Studio, MLX for Apple Silicon, Llama.cpp, K-Transformers, they're all adding or have added support.
So pretty easy to access one way or another.
Seems like it. They're making a push for accessibility.
Given all this, what kind of applications are we likely to see?
Well, the agent capabilities and tool use point towards more sophisticated assistance, maybe in specific industries like finance or HR, where reasoning and interacting with data is key.
Makes sense.
The multilingual aspect is huge for global products or services. Customer support bots, translation tools.
Right.
The smaller models, like the 4B or even the sub-billion parameter ones, could potentially run on mobile devices or edge hardware, opening up on device AI applications.
That's always the goal, getting powerful AI onto smaller devices.
And that thinking mode feature might be interesting for decision support systems, where understanding why an AI recommends something is critical. Education tools, perhaps.
Lots of possibilities. So wrapping up, what's the main takeaway here with Qwen3?
I think it's a combination of things. Impressive claimed performance, especially that efficiency we see with the MoE models and even the smaller, dense ones.
Huh.
The open-weight Apache 2.0 license is a massive plus for accessibility and commercial use. The sheer breadth of the model family offers options for different needs and hardware constraints.
It definitely feels like another significant step in, well, democratizing access to pretty powerful AI tools.
It does seem that way. Puts more capable models in the hands of developers who might not have access to the proprietary giants.
So the final thought then. With models like Qwen3 pushing performance boundaries while being open, what does this mean long term?
That's the big question, isn't it?
Yeah.
How sustainable is the dominance of closed proprietary models when open alternatives are improving this rapidly?
Right. Will we see a shift? Or will the biggest players always stay one step ahead?
And maybe more excitingly, what completely new applications will developers build now that they have access to this level of open capability?
Yeah.
What haven't we even thought of yet?
Something for all of us, and especially you listening, to think about. What will you build? Thank you very much for listening. Leave a like and subscribe. Until next time.